So getting back to this point of mine design workflow, this is the summary. Let's assume that by using MiningMath, you are developing your decision tree with over 100 scenarios. So you have the base case, you have scenario 1, 2, 3, 4, 5, 6, 7, 8. You have hundreds of scenarios, and you selected the one which makes sense, which makes the most sense not only for the board but also for the stakeholders. So this is the best scenario you'll have to move the project forward. Okay, and all these you can do all these evaluation, these robust trade-off analysis without spending too much time on that manual work, which is the mind design. So you run these more mathematical results, let's say, with a given aspect of operationality, of geometric constraints. Minimum bottom width is mining width is vertical rate of advance, and then you have a solution that is mathematical but is also more coherent with reality. Okay, and without spending so much time on designing ramps and axes, etc. And so you select the best scenario, the best group of project assumptions you want to move with. So that's the idea, where MiningMath can help you to exceed and to create value. And by doing so, our users and the companies exploring the technology are being able to achieve up to 68% increase in net present value. So I know that this is huge, but on average, gains are ranging from 10 to 20%. These considering, again, billion-dollar project, so we are talking about hundreds of $1 million of opportunities hidden, and that could be uncovered when we have these more robust decision tree. Okay, so that's the first point. By having your multiple scenarios to evaluate what is the best one. Okay, I have selected my best one. Then I can start, only then I can start iterate and to do the mind design work, which is still necessary to make the scenario even more close to what operations need. Okay, so the idea over here is that I will take this best scenario and I will have my topography here highlighted in yellow. I will have the mind sequence highlighted over here or illustrated here in the black line. So imagine these are the surfaces from MiningMath. And I will take just the first one. So let's say I'm taking the first surface, which is in a grid of points format. It's more not fully operational because it doesn't consider ramps, axes, etc. But I will design the surface in another software, or I will use the surface as a basis to my open pit mine design. So the next step is to design this pit for period 1, and then I will have something like this in red. Okay, and then I will re-optimize my mine schedule with this surface over here being fixed, being considered a fixed solution, as I explained before. So this surface in red over here, it will be used in both fields, forced mining and restricted mining, and this will be applied from 1 to 1. Okay, so that's the idea I was talking about. This surface design will be applied over here. Okay, from 1 to 1, design 1, design 1. Okay, and by doing so, I will re-optimize the scenario as it is right now. And by doing so, I'm giving more flexibility for the mine sequence to change from periods 2 up to the end of the life of mine. Okay, so that's the idea. I will re-optimize the mine sequence. The mine sequence can change. I can have some deviations, things that were evolving this direction and that could change in the opposite direction, etc. Because I fixed this solution, and this solution is still is also slightly different from this one. Maybe to make this more operational, I might need to mine more waste, etc. And this flexibility for the remaining years will be quite important to try to recover as much value as possible for the forthcoming years. Because here, when we make the solution for period 1 more operational, having axes, ramps, etc., we are making it more operational. And by doing so, we are getting close to reality. And by doing so, we will have a lower NPV, but this NPV is more realistic. But still, I have the possibility of re-optimizing this scenario to find new opportunities to recover the value for the forthcoming years, especially considering I lost value when I make these more operational. Okay, so it's a way of counting on the flexibility from the algorithm to see what if there's an opportunity to recover the value that has been lost when I designed my bit and when I made it more operational. So that's the general idea of giving such flexibility for the algorithm. Okay.